So welcome to the fourth workshop. Today I'd like to talk about co-simulation of coil arrays. Last time we just looked at a co-simulation of a single array, but now let's look at a more practical example. And then next we will talk about scripting in HFSS, how it can be applied to modeling, how it can be applied to set up a simulation, and export the data. So first, co-simulation of coil arrays. So I don't want to bore you by modeling here because basically I just took the example that we were working on since the first workshop, which is the single coil. I added another port on the loop itself. So now the loop has two ports. So one port is intended to be the feeding port with a matching network, and the other port is intended to have a tuning capacitance. And then I just copied it, and it's a two-port, two-channel array with a phantom in the middle. And I simulated it, and it gives a S matrix. We can have a look at that S matrix, how that looks like. Maybe in MATLAB is easier for me. So I exported that S matrix. We discussed that already, but I'm going to show it again. I exported it by choosing results, then solution data, and then you can find here export, and you can just export the matrix data to a SNP file. Yes. And then in MATLAB, for example, we can import it. No, that would have to be. No, I'm gonna just open the text file. It's easier. Sorry about that. I would have to look up 5 minutes how to import it, but. Where do I have it here? So yeah, this is how the S matrix looks like. We have amplitude and phase. So yeah, it's a complicated matrix, and we want to match that. I guess I could just try to copy this into MATLAB, and then we can have a look and plot it. But yeah, I don't want to do that. It will take some time. So yeah, it's a matrix. It has complex values in each component. It's a 4x4 matrix, and that then we can use co-simulation to try to match that. So I set up already a circuit diagram. I imported the model that we had, which has the S matrix inside, and I want to drive it at port 1 and port 3. So these are my driving ports, and I have a parallel capacitor, and on the tuning port I have a capacitor in series on both coils. So I did that, like I computed the capacitors before already, and to give me a match in the excitation port. So then we can plot we can analyze it, and then we can plot the results, and we can see that both coils are matched. So yeah, as I said last time, this can be also done without co-simulation, but that process, yeah, it you would have to make like 50 simulations to figure out the proper value of the tuning capacitor and the matching capacitor. But if we replace the capacitors with excitation ports, we can have variable capacitors instead and do this process of tuning and matching in co-simulation. And yeah, we can see that we can match the coil in this way. So yeah, that's the co-simulation part of the array. And now let's talk about scripting in HFSS. I'm gonna open a new design for that. So how I do scripting, I mean, either probably in the help menu there is scripting help, and you can look up all the different commands that are needed. What I prefer doing is to use this function. You can select tools in the menu bar and select record script to file. You can give it a name. Workshop 4. And then you can just draw whatever you want to draw. Let's say we want to build a dipole array. So I will make like a dipole. Assign these perfect electric conductivity. And here a port, for example. And then we can also, so we set up the boundaries, we set up the excitation, we can give like a local mesh, assign mesh operation on selection, length based. So let's just say 0.2 millimeter. My PC is a bit stuck right now. So we can assign it an amended solution setup. Sure. Can delete this. So yeah, we set up like a whole simulation. Now I can say, or yeah, maybe let's just quickly do the radiation boundary. Quickly validation check. Okay. So we designed this whole model, and now I can say tools stop script recording. And now let's go and have a look at the text file that we produced before. So all of what we did in generating this model is saved in this Python file. And that Python file we can just have a look at. And here we can see what he did. I mean, first let's just test what he did. Let's delete this whole design. Yes. So now it's gone, and now we can say run script, and hopefully we need to select Python file because that's what we saved it in. Because there is different script options. I think VB script is the old scripting language of HFSS, and now they switched to Python, which is easier and more intuitive. So let's run workshop 4. I hope he will do something. Yeah, sorry, my PC is slow.
Did it give an error? Yeah.
Sorry?
Did it give an error? It says error executing script in it gives the workshop 4.py.
Actually, you know what? My internet connection is kind of interrupted. I think I need to reconnect it to my computer.
Okay.
I don't see that on my screen.
Oh, I see it. I see it here in the global messages. It says error executing script.
Okay, thanks. It will take a little bit because I need to reconnect my internet. There's something going on. I'm talking through my phone, but my remote connection is now interrupted.
Yeah, same here. I talk through my phone, but I connect remotely. So.
Okay, I need to reconnect again to my office to see. Yeah, I think I need to insert the design again and then run the script. I forgot about that. Okay, now I have internet and now I need to log in remotely. Okay. Sharing. Yes. Now I can see it. Call failed. Okay. I think the issue is because when I started to record the script, I had the design inserted already, but I could have started it before. So I don't know if it's my connection or not. Yeah, HFSS design 2. Let me see what's the name of the HFSS design 1. So you want design 1. I'm going to try to rename this. There is already designed by that name. I think I need to save it. Because whenever I insert a design, I can't use the same name unless I delete it, but then I need to save it again, I think. So let's see. Yeah, now I can do design 1. But just for fun, we can just see what happens if I say here design 2, and I can change in my script, I can change here design 2. So now I hope that if that was the issue, then now it should run. To run script. Yeah, and you can see it creates that model. So now you can ask yourself, like, why do I do this? Why don't I just create the model? But this is very powerful because you can manipulate this text file, and you can either do it. The most straightforward way to do this is in Python itself, because this is a Python script. But I'm not that good in Python, or I'm too lazy to learn it. So what I do is I do it in MATLAB. I use MATLAB to create this Python file that then can be evaluated or then can be run by HFSS to create a script. So I can show you an example that I was working on, that I'm working on with Start to create a coil array. Let me navigate to this file, head array. just an offset, let's say. No. So yeah, that's, I'm gonna, so this is just to give you an example. I don't want to go like into details of how this works, just like roughly. This is a like MATLAB file, and I'm trying to create two loop coils, and those loop coils are defined by their diameter, by the angle. It's going to be a head array, and it's going to be those coils going to be rotated around a sphere. So then they're defined by the diameter, by the angle of theta, it's in spherical coordinates, by angle phi, by the distance from the center, and the conductor width. So those are those four parameters that describe the coil, and then those parameters are then given to a second subfile. Let's see how that looks like. And that file already has, you can see, create a text file. So I'm writing into a text file, and I call it, I'm giving it a name, head array model. And there I will basically write those script commands that the HFSS wants to see. So if you see here at the top, that's exactly what's here. Script import script ends. So I just write that, and then I'm running through a loop, and that loop creates more of this text file. So let's just run it. Create test call array 1. Just for you to see what you can do with this. File name head array model. So now let's navigate to this Python file that I just produced. So this file here that was produced today at 2:24, so that's right now. So that's the file that I created with MATLAB. We can have a look how that looks like. But I'm gonna run it with HFSS, and meanwhile we can have a look how that file looks like, because it will take some time until it's finished. So that's the Python file that's running in the background in HFSS. Yeah, and here's like these different commands. We like it's a little intuitive, a little bit. Like here it says create sphere. Then you're giving these parameters of the center and the radius. Here's some circles created, another circle is created. Then you subtract the circle. So I kind of create a coil that way. Yeah, it's a little bit intuitive, so you can actually go and edit those numbers here with a different program. Yeah, you can do it with Python itself if you know it already, or if you want to learn it. That's probably a good thing. But yeah, I'm doing it in MATLAB, and it works for me. So and that way you can like create very variable models. Let's have a look. I think it's finished now. So this is the model that we just created. Let's hide this numerical domain sphere. Yeah, and this is the model that we just created. And yeah, we can like it's very flexible, because like I can create those coils very easily by just giving it like 2 or 3 parameters for spherical coordinates, the width and the radius, and then those coils are created and like wrapped around the sphere of the phantom. we can create like different coil arrays to like quickly test them. So yeah, this is kind of the idea behind scripting. Yeah, I just like wanted to show you how like my approach is and how, like, just an example. Do you have any specific questions about that? Yeah, like if you guys are like or need a script for some simulation project, you can either you can ask me for help. But yeah, do you have questions about the first part, about the co-simulation? If not, this is basically what I wanted to show you today. We are done like 15 minutes early, so we just had half an hour. Shall we still have a break, or do we like, or do you guys want to continue for the like if anyone has questions? If no one has questions, then I would say we're done for today. Yeah, I don't have much more to talk about during the for the workshop. I just like trying to like reduce the barrier of like switching to a new software. But yeah, I don't want to go like much into detail of like of modeling, because like it's like kind of infinite amount of what you need to learn. So most of it probably you would have to work through yourself. But yeah, like if there is anything that you would want to hear about or like need help with, then we could like maybe try to continue the workshop for the next week if there's like a topic that you would like to hear about. Otherwise, I would have to think if I can come up with other ideas for like to fill like another half an hour. Otherwise, yeah, I don't have like any other like tutorial examples. I was thinking of switching like to different formats maybe next week if people have like projects, like simulation projects that they're working on in HFSS and that they need help with, then we can like continue it like that. But yeah, I need to think about it, and maybe on Thursday or during the group meeting we can discuss. Unless you have like some input now or like some thoughts about that.
Yeah, and so I was wondering if there would be, I mean, if you could like hold a session on phased array excitations and how to go about the different field patterns and stuff. Sorry, phased arrays basically.
Phased arrays excitation. I mean, that's more. It's not really MRI, right?
Yes.
Excitation. And like far field, or what do you mean?
So, so I was reading this paper on like different modes of a birdcage coil and like how they excite like different trunks or like with their different phases. So I was just like wondering if you, yeah.
Okay, can you send me the paper?
Sure. I will share it.
Yeah, if you could send me the paper, and then yeah, let's see if it makes sense like to discuss it during the workshop. But yeah, maybe yeah. Thank you for the input. Anyone else has another idea? So also maybe I should mention that I'm in contact with the like high performance computing center that like MCIT is running, and they have a cluster of like workstations, very powerful workstations. I think on one of them they have like a 1 terabyte RAM node, and I asked them to install HFSS on that cluster. So if that if they do that, then we can have also another workshop maybe on how to operate, or like how to submit job requests to that cluster. Because yeah, when that was working, that would be really great, because this software like HFSS needs a lot of RAM, so we can run like many models at the same time, or like very fine on a very fine mesh. Yeah, if no one else has like different input, maybe you guys can write me emails or call me. Yeah, thanks for the suggestions, Saad. Please send me the email. Please send me the paper. And otherwise, I think we can finish now. Yeah, thanks for joining, and talk to you on Thursday latest.
Hi, Jan.
Yeah.
Did you want to meet now or later?
I can meet now if you want. Maybe 5-minute break and then.
Okay, sure.
Okay. Yeah, we can maybe just stay in this.
Okay, sounds good.
Cool. Thanks. All right. Bye, everyone. Other than Anna, I mean.